Okay, so let's figure out if there isn't a formula for figuring out the resistance when you have multiple resistors in parallel. So let's use this as our example. Here we have 4 resistors in parallel. They're all the same size. They're all 40 ohm resistors. How do we figure out if there is some sort of formula we might want to use that will give us the equivalent resistance to these 4 resistors? Okay, let's go back and look at our first example of resistance, which were the 2 resistors in parallel. Okay, here are 2 resistors in parallel. They're both 10 ohm resistors, and there's a 5-volt battery. And if you remember, what we came up with as an equivalent was a single resistor. And our single resistor was a 5 ohm resistor. Now, how do we get from 2 10 ohm resistors to a single 5 ohm resistor? So we want to go from 2 10 ohm to 1 5 ohm. Is there some math that we could do? Is there a formula we could come up with? One of the ways of solving that is to put them on either side of an equal sign. So we have the number 2, we have the number 10, and we have the number 5. Okay, so our question is, how can we use the numbers 2 and 10 to come up with 5? And I'm sure you see it right away. So the simplest formula that we can come up with is 10 divided by 2 equals 5. Well, what do we have there? Well, we've got the size of the resistors, so I'll use the resistance sign there. And we have the number of the resistors, and that will give us the equivalent. So 10 divided by 2 equals 5. We have 10 ohm resistors divided by 2 of them, and we come up with 5. So let's take a look at our current example and see if that works. If we plug that into our current example, what size is our resistors? Are our resistors? Well, they're 40. And how many of them are there? 1, 2, 3, 4. So we want to come up with an answer that gives us a single 10 ohm resistor. So let's see if that works. Again, we are going to be taking the size of the resistor and we're going to be dividing it by the number of resistors, and that's going to be the equivalent. I'm going to go ahead and mark down the equivalent resistance over here. So the first thing we need to do is, as in eating an elephant, you do it in little bites. So let's go ahead and just concentrate on this part of it. So the first thing we need to do there is we need to solve and find out at that point what is the current. Okay? So let's make a guess and say that this battery is an 80-volt battery. You can see if we're going to use 80 and 40, it'll make the math kind of easy. So how do we figure out what the current is at R1? Well, we look at our formula, and our normal formula is going to be E equals I times R. If we want to solve for I is going to equal to E divided by R. Well, we know that E is 80 because we remember that the voltage is the same throughout the circuit. And we're going to divide it by 40, which is the resistance there. And we're going to come up with 2 amps. Okay, we can do the same thing at each of these places. So here we're going to end up with 2 amps, 2 amps, and 2 amps. Okay? So the total amperage of the circuit, since we know we have 2 here, and 2 here, and 2 here, and 2 here, is going to be 8 amps. So I total equals 8 amps. Now let's go ahead and solve for the resistance. What is the equivalent resistance of an 80-volt circuit with a total amperage of 8 amps? Well, we should be able to do that. We're now going to solve for R. So I'm going to say that R equals E divided by I. So R is going to be equal to 80 divided by I, which is 8, which is, how about that, folks? It comes out to 10 ohms. That's the equivalent resistance. And what is the formula that we developed before? It is the resistance divided by the number of resistors. So if we have resistance which is 40 divided by the number 1, 2, 3, 4, that equals 10. Okay? Now, this only works when all of your resistors are the same size. They all have to be the same size. Same size resistors is when that formula, the size of the resistor divided by the number of resistors, will give you the equivalent resistance of the circuit. Okay, that was kind of a long one, but resistance is pretty complicated. Thanks for watching.